Okay, so here we go, starting off 4.1, this is our second video. This is 4.1 continued. I will be starting with example number 2. Oh, there we go. So example 2 is finding the area of a parallelogram on a grid. So this one is a little bit different, but it kind of goes hand in hand. If you did the on your owns from the last video, it helps with number 2. Okay, so example 2 is finding the area of a parallelogram on a grid. So everything's the same here except for the units. So we're talking about putting in the units using graph paper. So I'm gonna take a picture from my book, and we'll work with that picture that I have, and I'll kind of show you. Just so you know, though, the area of parallelogram will always be base times height. Alright, so this is what they start off with. They give you a picture. Like I said, I just took this picture right out of my book on page 155. Let's put that up there just in case you want to look. And what they're telling you is to find the area of a parallelogram, you count the grid lines to find the dimensions. So the base B is 2 units and the height H is 5 units. And let me explain. So basically, if I were to draw a line straight down, and it goes all the way down to that grid paper, how many units did I go? So you're going to count how many boxes you moved down. Well, technically I moved 1, 2, 3, 4, 5. And that's where I get 5 units for my height. So my height equals 5 units. I'm using the word units because I don't actually know if those are inches, centimeters, etc. We just know that they're excuse me, we just know that they're units. So then it also tells me that my base is 2 units. I get my base because what line would run perpendicular or cross at a 90-degree angle? Well, my base would. So that's where I'm getting that from. Let me erase that real quick. Okay. So my base is this line right here. How many boxes do I have, or units, go over? 1, 2. So my base equals 2 units. So now I just fill in, and I remember I said this in the last example, area equals base times height. Area equals, I fill in for my formula, my base being 2 units times my height being 5 units. So my area would equal 2 times 5 is 10. 10 units. And don't forget to square it. So my answer on this would be 10 units squared. I just rewrote it up here so we could kind of see it. So just a short recap. Again, you're counting your height because that's the top of one of your bases, and this could also be considered the base. Remember, this and this are the same because they're parallel. But to recap, you have 1, 2, 3, 4, 5 units you go down. So my height is 5 units. And then over here, 1, 2, so I have 2 units. So my base and my height, and then you just do your multiplying and get your formula. I will do the on your own, but I'm going to wait till the very end. So there is an on your own question for this, number 4. It's on page 155 that I'll come back to. Example 3 is a real life application, and we're talking about a photo prop. So it says you make a photo prop for a school fair. You cut a 10-inch square out of a parallelogram shaped piece of wood. What is the area of the photo prop? So I took right out of the book this picture, and obviously you can tell by the picture it is a piece of wood that is a parallelogram. And I'm going to erase it now. So that's what they're talking about. We've learned that a parallelogram, the area of parallelogram is base times height. Well, the problem here is, well, we know our height is 8 feet. We know our base is 4 feet. Well, that's easy. We could just say 8 times 4. Well, our answer is 32 feet. Not necessarily, because there's a part of it that's cut out. The part that's cut out is where you would put your face for a little photo prop thing. So the part that's cut out is 10 inches. It says, let me get a different color here. You cut a 10-inch square out of a parallelogram shaped piece of wood. So if it's a 10-inch square, we have to find out what the area of that is in order to figure out what our area of our parallelogram is. So our first step would be convert the dimension of the piece of wood to inches. Right here we have feet. Right here we have inches. Those are two different types of conversions. So you have to understand that you need to make 4 feet into blank inches and 8 feet into blank inches. So in order to do that, you have to think about what do I do? Well, this is all prior knowledge. So you should be able to say that you take 4 and you multiply it by 12 because there's 12 inches in every foot. So 4 times 12 gives me 48. So this now is not 4 feet, it is now 48 inches. Then you're going to do the same thing for the 8 feet. 8 times 12, because there's 12 inches in every foot. So 8 times 12 gives you 96. So this is no longer 8 feet, it is now 96 inches. So our step 2 was converting. I just added the 2 in there for you. So let's start off with the area of the wood. To find out the area of the wood, we have to use area equals base times height. We know that our base is 48 inches. So right here is what our base is, 48 inches. Times our height, which is 96 inches. So that is something that is known. If you do out your work, you will come up with an answer of 4,608 inches squared. Okay, so that's our step 3. The next step that we need to do is figure out what is the area of the square. So you have to use some prior knowledge and know how to find the area of a square. Well, it's just side times side, or side squared. One side, so if I did step 4 is our area of our square. Area equals, for a square, side squared. Remember, this is prior knowledge. This isn't something we've gone over. I should be able to say, whoops, one side is 10 inches. It tells us right here. So 10 squared is what my area would equal. Well, 10 squared equals 100, because it would be 10 times 10. Remember, that also equals 10 times 10. Then the last step you need to do, and I'm going to kind of try and fit it in right here. Step 5 would be to say, okay, if I have this spot right here removed, this is gone, I know the area for this, wouldn't I remove this from the area that I already found? Well, here's the area I already found. I'm going to remove this part of it. I hope that makes sense. That is all I'm doing, is taking the area of the parallelogram, which is 4,608 inches squared, and I'm subtracting the area of the cutout, the 10-inch square cutout. So if I just subtract that, I should come up with 4,508, and it should be inches squared. Now, this problem did not tell me that I needed to put it back into feet, because it just says what is the area of the photo prop. I just need to know the full area. I switched it to inches because I had to, because I started off with inches here and feet here, but we're going to leave it in inches for the example. So it's 4,508 inches squared. The next slide will show you your practice problems, and then it will go on to your on your own. So as of right now, the video is pretty much finished. You just have a couple practice problems to do, and then I will go through some more on your own questions from the book. So stay tuned if you want to. If not, at least check over and do a couple and see that you're doing them correctly. So your practice problems to use for twirl groups the next day. Big Green, page 156 through 157, numbers 11, 13, and 15. These have to be done or it's a homework pass. And all three of these answers are in the back of your book. So figure out, do the work, check it with the back of the book to make sure that you're on the right track. The next slide will be the on your own. So if you still need additional help, please refer to those next few slides.